Electrical metallic tubing, or IMT, is not permitted for use when feeding motor starters or motors that are connected to a 4160 volt service, especially not in New York City. The New York City Electrical Code, specifically Article 368 within the 2020 edition, dictates the acceptable conduit types for such high-voltage applications. This code mandates the use of either rigid metal conduit, or RMC, or intermediate metal conduit, or IMC, under specific conditions. These conditions include conductors or cables operating at over 600 volts, nominal, as outlined in Section 368.10 services, as detailed in Section 368.14, and feeders, which are covered in Section 368.16. Because the scenario involves feeding motor starters and motors from a 4160 volt service, the electrical code requires the use of RMC or IMC for the conduit run in the mechanical room ceiling. ENT, which is a thinner-walled conduit, doesn't provide the necessary mechanical protection and grounding capabilities required for high-voltage systems. RMC is a heavy-duty, thick-walled conduit that offers superior physical protection and is suitable for direct burial, exposure to severe physical damage, and other demanding applications. IMC is a lighter-weight alternative to RMC but still provides significant mechanical strength and is permitted in many of the same applications as RMC. The selection between RMC and IMC may depend on specific project requirements such as weight considerations and cost factors. However, both options meet the code requirements for high-voltage installations. Firstly, understanding the voltage level is critical. Any electrical system operating above 600 volts, nominal, is considered high voltage. The 4160 volt service falls squarely within this high voltage category, making the selection of appropriate conduit even more crucial. Secondly, the New York City Electrical Code adopts more stringent requirements than the National Electrical Code, or NEC, in some areas. It is essential to adhere to the local codes and regulations. Article 368 in the NYC Code specifically addresses cable supports in high-voltage installations, and it references the NEC requirements but also adds additional stipulations. Thirdly, the type of occupancy and environment where the conduit is installed plays a role in the conduit selection. In a mechanical room, there may be exposure to moisture, chemicals, or physical damage. RMC or IMC provides better protection against these factors compared to EMT. The grounding requirements for high-voltage systems are more stringent than those for low-voltage systems. RMC and IMC provide a more reliable grounding path compared to EMT, which helps to ensure the safety of personnel and equipment. The installation of RMC or IMC requires specialized tools and techniques. These include pipe threading machines, conduit benders, and specialized fittings. It is important to use qualified electricians with experience in high-voltage installations to ensure the work is performed safely and correctly. The code also addresses the sizing of the conduit based on the number and size of the conductors. It's crucial to perform the calculations to ensure the conduit is adequately sized to prevent overheating and voltage drop. When installing RMC or IMC, proper supports and fasteners are required to maintain the integrity of the conduit system. The spacing between supports is dictated by the code and depends on the size of the conduit. In addition to the conduit itself, the fittings and connectors used in a high-voltage system must be rated for the voltage and environmental conditions. Using the wrong type of fitting can lead to insulation breakdown and electrical failure. Furthermore, periodic inspections and maintenance are required to ensure the continued safe operation of the high-voltage system. This includes inspecting the conduit for damage, checking the tightness of fittings, and testing the grounding system. The 2020 New York City Electrical Code references various standards and publications, including those from the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. These standards provide detailed information on the design, installation, and testing of electrical equipment and systems. The code also addresses the use of cable trays for supporting conductors. While cable trays are permitted in some high-voltage applications, they must meet specific requirements for construction, grounding, and fire resistance. It's essential to consult the code to determine if cable trays are an acceptable alternative to conduit in a particular situation. The use of flexible metal conduit, or FMC, is generally limited in high-voltage applications. FMC may be permitted for short runs to connect equipment, but it must be properly grounded and supported. The code also addresses the use of liquid-type flexible metal conduit, or LFMC, in wet locations. LFMC provides a waterproof seal to protect conductors from moisture and corrosion. This selection of conduit for a 4160-volt service involves a careful consideration of several factors, including the voltage level, the environmental conditions, the occupancy type, and the applicable codes and standards. By adhering to these guidelines, it's possible to ensure the safe and reliable operation of the high-voltage system. A 4160-volt system is considered a medium-voltage system, meaning that special care must be taken when dealing with this level of voltage. The use of RMC or IMC helps to provide a safe and reliable electrical installation. Additionally, consider the type of conductors being installed within the conduit. High-voltage conductors often have thicker insulation than low-voltage conductors. This thicker insulation requires a larger conduit size. Therefore, it is critical to perform a conduit fill calculation to ensure that the conductors can be properly installed without damaging their insulation. The New York City Electrical Code also provides specific guidelines for the bending radius of conduit. The bending radius must be large enough to prevent damage to the conductors during installation. Using the proper bending equipment is critical to ensuring that the conduit is bent to the correct radius. Furthermore, the code requires that all conduit runs be properly supported. The support spacing depends on the size of the conduit and the type of support being used. Using the correct support spacing helps to prevent the conduit from sagging or becoming damaged. The installation of high-voltage systems requires a thorough understanding of the applicable codes and standards. It is important to consult with a qualified electrical engineer or contractor to ensure that the installation is performed safely and correctly. In addition to the conduit itself, the fittings and connectors used in a high-voltage system must be properly rated for the voltage and current being carried. Using the wrong type of fitting can lead to overheating, insulation breakdown, and electrical failure. Therefore, it is critical to select fittings that are specifically designed for use in high-voltage systems. The New York City Electrical Code also includes requirements for the grounding of high-voltage systems. Proper grounding is essential for protecting personnel and equipment from electrical shock. The grounding system must be designed to provide a low impedance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or fuse, preventing a dangerous voltage from building up on the equipment. When working with high-voltage systems, it is essential to use personal protective equipment, or PPE, such as rubber gloves, insulated tools, and arc flash suits. This equipment helps to protect workers from electrical shock and arc flash hazards. Furthermore, it is important to follow safe work practices such as de-energizing and locking out equipment before working on it. The New York City Electrical Code also includes requirements for the labeling of high-voltage equipment. Equipment must be labeled with the voltage, current, and other relevant information. This helps to ensure that workers are aware of the hazards and can take appropriate precautions. The inspection of high-voltage systems is an important part of ensuring their safe operation. Systems should be inspected regularly to identify any potential problems, such as damaged conduit, loose connections, or overheating components. Any problem should be corrected promptly to prevent a more serious failure. The use of infrared thermography can be a valuable tool for inspecting high-voltage systems. Infrared cameras can detect hot spots, which may indicate loose connections or other problems. This allows electricians to identify and correct problems before they lead to a failure. The 2020 New York City Electrical Code also addresses the use of surge protection devices, or SPDs, in high-voltage systems. SPD help to protect equipment from voltage surges caused by lightning or other transient events. The code specifies the types of SPD that are required and how they must be installed. Furthermore, The code includes requirements for the testing and maintenance of high-voltage systems. Systems should be tested regularly to ensure that they are operating properly and safely. Maintenance should be performed as needed to keep the equipment in good condition. Training of electrical workers is essential for ensuring the safe operation of high-voltage systems. Workers must be properly trained in the hazards of high-voltage electricity and the safe work practices that must be followed. Training should include both classroom instruction and hands-on experience. The New York City Electrical Code is constantly evolving to keep up with new technologies and safety concerns. It is important to stay up to date on the latest code changes to ensure that electrical installations are compliant. The use of RMC or IMC for high-voltage applications is a critical safety measure. These types of conduit provide superior protection for conductors and help to prevent electrical shock and fire hazards. Always consult the applicable codes and standards before installing or working on high-voltage systems. Remember to prioritize safety and use the proper tools and equipment. The ultimate goal is to create a safe and reliable electrical system that will provide years of trouble-free service. In summation, for a 4,160-volt service in New York City, relying on E&T is not an option. The mandate is RMC or IMC, providing the robust protection needed for high-voltage conductors and services, feeders, and other critical applications, ensuring a safe and code-compliant installation.